child pulls a sledge of mass 8 kilograms along a rough horizontal surface using a light rope. The coefficient of friction between the sledge and the surface is 0.3. The tension in the rope is 40 newtons. The rope is kept at an angle theta to the horizontal as shown in the diagram. Model the sledge as a particle. Draw a diagram to show all the forces acting on the sledge. Find the magnitude of the normal reaction force acting on the sledge in terms of theta. The acceleration of the sledge is p plus q cos theta plus r sin theta. Find p, q and r. Okay, that's the question then. I've got it summarised here. So first of all we need to draw all the forces, don't we? This is of mass 8 kilograms, so this is 8g acting downwards. We'll have a normal reaction force here, which we'll label r. As it's being pulled along, we'll have a frictional force mu r, so that's 0.3 r. It's going to be pulled along and it's going to have an acceleration. So let's label that as a, the acceleration here. Okay, so that's what we've got then. So there's no acceleration vertically. So that's all the forces involved: the weight, the friction, the reaction and the tension in the string. So draw all the forces we've done. Find the magnitude of the normal reaction. So let's resolve things vertically then. Gives. So there's no acceleration vertically, so we can resolve the forces and they equal 0. So r plus 40 sine theta. It's 40 cosine of this angle, and this is a 90 degree here, so this would be sine of this angle. So it's 40 sine theta minus 8g equals 0. So we can now write down r. So that tells us then that r is equal to, move the 8g over to plus 8g, and move the 40 sine theta over to minus 40 sine theta. So there's our reaction force then, in terms of theta. Find the acceleration is this. Find p, q and r. So let's resolve horizontally now and apply F equals ma. Gives. So horizontally then, what forces have we got? We've got r 40 cosine theta minus 0.3 r going backwards. So it's 40 cosine theta then minus the 0.3 times r is equal to the mass, which is 8, times the acceleration a. So that tells us what acceleration is then. A is equal to, move the 8 from times to divide on this side. 40 over 8 is 5 cosine theta minus 0.3 over 8, isn't it? The 8 comes underneath the whole side, which is 3 over 80, which we'll write it like so, of r, which is 8g minus, putting it in, 40 sine theta, is the a. So that's equal to then. Now we want to write it in the form of p plus q cos plus r sine. So put the constant term first then. 8 over 80 is 10. So it's minus 3g over 10. When we expand this bracket here, 8 into 80 goes 10 times. And then the cos was next, so it's plus 5 cos. And then minus times a minus is a plus. 40 over 80 goes twice, so it's 3 over 2, isn't it? Sine theta. So the p is equal to minus 3g over 10. The q is equal to 5, and the r is equal to 3 over 2. And let's just check that then, that we've got p, q and r the right way around. p, q, q cos r sine, which is fine.